Hello everyone. Today we'll be discussing on topic of bidirectional constraints. What bidirectional means and how do we use it as constraints and how constraint solver sees a constraint as a bidirectional. So SV constraints are solved bidirectionally. All the SV constraints. So what does that mean? That means constraints on all the random variables will be solved in parallel. And how does that happen? So suppose we'll write a constraint and its name is CNAME. So if we'll write it, if A equals to 0, B should be 1. Else B equals to 0. So when A will be 0, B will be 1. Otherwise, when A will be 1, B should be 0. Okay, we'll write this as a constraint. Now we will see that B is dependent on A only. Okay, but that's not how constraint solver will see it. Constraint solver will see it as A is dependent on B as well as B is dependent on A. Okay, so it goes both the ways. B is also dependent on A and A is also dependent on B. And how does that happen? Let's see in the example. Suppose we wrote an inline constraint with B equal to 1 and we have constraint B as 1. So if we have constraint B as 1, then only this loop can happen. Okay, so what A value will be constrained at? A value should be, A will always take a value as 0. So that's how we can say if we'll constrain B first, then A is also constrained. And suppose if we'll constrain A, then B is also constrained. So that's why we will call this as bidirectional constraint. Okay, and constraints are considered from all the aspects. That's why. So let's see an example. In this example, constraint A value, B value, and C value is written. A will always take the value of sum of B and C, and B is always greater than 6. C should always be less than 8. Okay, and we'll randomize this, and let's see what it gets. A will always get a value which will be sum of B and C. Let's see. In the first iteration, B will be equal to 8, C equal to 0, and A is 8. Similarly, as it is a 4-bit variable, so 14 plus 2 should be 18, which will exceed the register value. So it is written as 0. Otherwise, when B is 14, C is 0, A is 14, 15, 7, which will exceed, and A will get 6 value. Okay, that's how it is written. Let's see another example. Okay, suppose here we have constrained the value of A. Okay, let's not consider this inline constraint in the first time. So when we will constrain A equal to 1, and we have written if A equal to 0, B should be 1, else B should be 0. So if we have already constrained A as 1, then B value should always be 0. Okay, this is one point. Let's write it down. If A equal to 1, then B should always be 0. Okay, this is one point. Let's see the bidirectional nature. So if we'll randomize, while randomizing, we'll write an inline constraint as B equal to 1. So suppose we wrote B equal to 1. Let's see. If B equal to 1 we'll write, then A should always get value of 0. Okay. This should happen. But what we are seeing here in the above value, A value should always be 1. These both constraints are conflicting with each other. So there will be a constraint inconsistency failure in this example. So that's how we can say that constraints are bidirectional. Okay. So instead, if we'll write A equal to B, we see that B is dependent on A, but the constraint solver will see that A is also dependent on B. Okay, that's the conclusion of this video. Thanks for watching.